Well, in the previous examples of finding electron configurations through the element neon, we actually were following something called the lowest n plus L rule. But now actually beyond neon, things start to get a little more interesting. In order to know the lowest n plus L subshell, where we need to put electrons in, I think there is a good way to do that using this little device called the arrow diagram. I'm going to warn you ahead of time that actually you're going to need to draw this for your exam. Draw this on your Unit 2 exam. Draw it and actually use it. So the arrow diagram, what does it look like? Well, here's what it looks like. If you need to draw the arrow diagram, here's what you do. You put the subshell 1s, and then when n is equal to 2, you have a 2s and a 2p. When n is equal to 3, you have a 3s, 3p, and 3d. Now make sure that you take care and line up your columns, okay? Don't get too sloppy on me. When n is equal to 4, you pick up the f. So 4s, 4p, 4d, and 4f. I said don't get too sloppy on me, but don't get too sloppy on you, because it's hard to read your own arrow diagram if you don't line these up. Now the F-type subshell is all we need actually to find homes for all electrons, for all elements, as long as those electrons are in their ground state. So when n is equal to 5, we don't really have to worry about 5G, even though it exists. So with n is equal to 5, do 5s, 5p, 5d, and 5f. And you actually have to go to 7. So we have 6s, 6p, 6d, 6f, 7s, 7p, 7d, and 7f. Okay, so are we good with that? Well, here are the arrows. The arrows actually are kind of like diagonals. They start in the upper right and go to the lower left. So here's our first diagonal. Oh, here's all of our diagonals. Now this is where, if you haven't been careful with your rows, or I guess your columns. If you haven't been careful with making sure things line up in a column, these are kind of tricky. So the thing about the arrows is each arrow, each line, each arrow actually represents an n plus L value. Okay, so n plus L value of 1s is 1 plus 0, because an L value of s is 0. N plus L value of 2s is 2. The n plus L value of both 2p and 3s is 3. Now here actually, and I think I mentioned this before when I was talking about it. Oops. What color do I want? I'll pick purple. Okay, so these guys, they have the same n plus L value, but I said, or the rule is that you start with the lowest n and then you go to the next lowest n. So the way these works is we're always going to start at the top of the arrow and move down. 3p and 4s both have an n plus L value of 4. 3d, 4p, and 5s, all three have an n plus L value of 5. 4d, 5p, 6s, n plus L value of 6. And then we get really fancy. We have these 4 subshells, 4f, 5d, 6p, and 7s, all have an n plus L value of 7. You can convince yourself if you want to. Then we have n plus L values of 8 for 5f, 6d, 6p, n plus L values of 9. Okay, n plus L value of 10. Wow, that's crazy. So when we load electrons, we're actually always going to start at the top of the arrow, go ahead and fill the subshells as we go, okay, and then we're going to go to the next arrow, okay? So that's the deal. Let's look at an example. This actually then, this next one right here, I think this is the arrow diagram that your textbook has, but I kind of like my own arrow diagram. It's what you get used to. But it's very similar. You complete this diagram, you complete this diagonal, this diagonal, this diagonal. They're just kind of telling you, the dot dot dots are saying go up at the top of the previous one, okay? So let's do an example. Let's pick on potassium. Now, potassium is a little more complicated than even neon. We need to, it's atomic number 19, so we need to find homes for 19 electrons. So actually up here, you're going to see kind of the builds for this slide use this arrow diagram. Okay, so check this out. And again, we need to completely fill a subshell before we go on to the next subshell. Okay, at least in the ones that you need to understand and work for the test. So we're going to start with the first diagonal. We're going to completely fill it. And as we completely fill it, sorry, how do I say this? The first diagonal only has one subshell. That subshell is 1s. How many electrons can we put in 1s? 2 electrons. We're on our way to 19. Then we go on to the next diagonal, which is which subshell? 2s. And we completely fill that subshell with 2 electrons. Now we have 4 electrons. This is like what? Beryllium, right? Where are we going to go next? We're going to go to the top of the next arrow, the 2p. And are we going to completely fill it? Yes. Why? Because now if you're adding up, and again, I kind of encourage students to add up as you go. If you add up these numbers, they add up to 10. So actually we are like neon. Now where are we going to go? We're going to go to the 3s and we're going to put 2 electrons there. Oops, I forgot on my builds. I go ahead and dun-dun-dun, say that you've arrived at neon. We'll be talking about that a little bit later too. So after the 2p, we go to the 3s, and we can fill it with 2 electrons. We've got 12 electrons there, right? Okay, we're going to go on to the top of the fourth arrow. Which subshell do we go to next? We go to the 3p, and we need to go ahead and completely fill it. I know at this point I have, what, 16 electrons represented. 10 plus 2 plus 2 plus 6, I have 18. Oops, excuse me. Actually, we have arrived at the rare gas in the next period. So that rare gas is, dun dun dun, argon. Perfect. Well, I better slow my horses down because I need only one more electron. Where is that one more electron going to go? It's going to go in the 4s. 4s1. So hope that works for you. They're kind of fun, and if you have your arrow diagram drawn, they're not very stressful, I think.